This is the page we're on, the NoHub page of Wikipedia. While I was covering this page, I came across this link called redirecting. And realizing that redirecting is the same topic which includes this part. My purpose was to cover this, NoHub, because I hadn't covered it yet, and then also this part, which is new to me, which I hadn't covered, especially the &1. Okay, so those are covered by the topic of redirecting. Okay, so I clicked on redirecting, and I happened to find what I was looking for, the &1. As a matter of fact, this whole page is very interesting, so I'm going to go through it also in this video. In computing, redirection is a function common to most command line interpreters, including the various Unix shells that can redirect standard streams to user-specified locations. In Unix-like operating systems, programs do redirection with the dup2 system call. Dup2, it's a function in the C programming language. It's not found in the bash shell scripting. Or it's less flexible, but highly... Okay. I'm more concerned about the Unix shells that can redirect standard streams to user-specified location. I'm not doing any programming in C language. And because I'm using PHP, and I'm using functions in PHP which execute command lines, which I believe they are interpreted by the shell, which is bash. Okay. They have a section here. Basically, I'm not going to cover things that I've already covered in other videos, like the standard redirection. I'm just looking for the new stuff. The greater than sign redirects the output to a file, and this will clobber any existing data in that file. The less than sign redirects input for the command from this file, and the input that's being redirected is the standard input, and the output here that's being redirected is the standard output. And you can combine both of these, and the order doesn't matter, so you could have this part over here if you wanted to, and then move this over here. The double greater than sign is like this one up here, but it won't clobber. It'll append to the end of file 1. Here are some variants. To read from a stream literal, which is an inline file passed to the standard input, one can use a here document, which is also called here doc, using the double less than operator. To read from a string instead of an inline file, one can use a here string using the triple less than sign operator. Here's another example. Okay, piping.
Piping.
Piping. Programs can be run together such that one program reads the output from another with no need for an explicit intermediate file, like this. This executes command 1 using its output as the input for command 2. This is commonly called piping, and this character is known as the pipe. The two programs performing the commands may run in parallel with the only storage space being working buffers, plus whatever workspace each command's processing requires. This produces the same end result as using two redirects and a temporary file, as in command 1 to temp file, command 2 gets its input from temp file, and then the temp file is deleted. But here, command 2 does not start executing until command 1 has finished. Here's an example where command 1 is piping its output to the standard in of this command, which is outputting its standard output to a file. In this section over here, which is called redirecting to and from the standard file handles, we are introducing these numbers which appear around the greater than sign. Yeah, it's pretty much the greater than sign. In Unix shells, derived from the original Bourne shell, the first two actions can be further modified. What are the first two actions? We're going to look at the specific examples. Oh, the first two actions, they're talking about this one and that one, which is directing output to a file or directing input from a file. Can be further modified by placing a number, which is the file descriptor, immediately before the character. This will affect which stream is used for the redirection. The Unix standard I/O streams are 0 is standard in, 1 is standard out, and 2 is standard error. For example, command 1, and you're redirecting the number 2, which is the standard error, to a file. Executes command 1, directing the standard error stream to file 1. In shells derived from C shell, and this would include bash, the syntax instead appends the ampersand character to the redirect characters. Appends, that means afterwards, thus achieving a similar result. What they're leading up to is this right here. The reason for this is to distinguish between a file named 1 and the standard out. 1 is for the standard out. But if you put it like this, 1 could be misunderstood as a file named 1. Another useful capability is to redirect one standard file handle to another. What that means is, here's 2 is one handle, and 1 is another handle. So here you're redirecting one standard file handle to another. The most popular variation is to merge standard error into standard output. So error messages can be processed together with, or alternatively to, the usual output. Example, here they're running the find command on the root directory with an argument of profile. They're outputting the standard output to a file called results. Also, the standard error is also being redirected to standard output, which is going to results. This will try to find all files named .profile. If this is executed without redirection, it will output hits to standard out and errors to standard error. If standard output is directed to file results, error messages appear on the console. To see both hits and error messages in file results, merge standard error, which is 2, into standard out, which is handle 1, using this notation. If the merged output is to be piped into another program, the file merge sequence 2 greater than ampersand 1 must precede the pipe symbol. Thus, here they are not redirecting to a file, but they are redirecting to the program less. So the 2 greater than ampersand 1 needs to go right next to this right here. This cannot come over here. We're talking about this right here, where they put these before this, whereas up here we have this following this. So it says, note, it is possible to use 2 greater than ampersand 1 before the greater than, but the result is commonly misunderstood. The rule is that any redirection sets the handle to the output stream independently. So 2 greater than ampersand 1 sets the handle 2 to whatever handle 1 points to, which at that point usually is standard out. Then the greater than redirects handle 1 to something else, for example a file, but it does not change handle 2, which still points to standard out. In the following example, standard output is written to file, but errors are redirected from standard error to standard out. In other words, sent to the screen. Here's the example. To be continued as usual.